Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we will look at parallel circuits. Now in a previous video we looked at series circuits where the resistors were one right after the other. In this video we're going to look at a parallel circuit, and so what we have is resistors that we say are in parallel with each other, or that the resistors are side by side. They have parallel paths for current to flow. So if we look at this, we still have our voltage. Let's go ahead and say it's 5 volts. And we have a total current. Here's R1 and R2. So we've got a total current, and what happens is when the current gets to this junction, the current splits, and part of the current goes this way and part there, so we'll call that I1 and I2. And what we have to remember is that total current gets split. It's like a branch in a pipe, or going a river splits into two branches. And so that we know that I total, the total current, has to be equal to I1 plus I2. We also look at this, and because there's nothing in the circuit until we get to this branch of the resistors, this voltage across the battery has to be the same as the voltage across R1 and voltage across R2. So in a series circuit, the voltage across each resistor, parallel circuit, voltage across each resistor in the parallel circuit have to be equal. And in this case, since there's nothing else in the circuit, that's going to be our V total, or our voltage of our battery, or 5 volts. Now, we can find, or we can calculate, the current through each of those branches. So if you go and remember our calculations, we had that voltage equals current times resistance, but we're trying to find the current, so we know that the current I is equal to the voltage over the resistance. And I'm going to make this resistor 1 ohm and this resistor 2 ohms. And so the voltage across, the current through R2, so the current through R2 is equal to the voltage over the resistance of R2, which is 5 volts divided by 2 ohms, and that gives us 2 1/2 amps. Okay, now the current through R1, and I probably should have done R1 first. That is, again, the voltage over that, the voltage over the resistance of R1, and that is 5 volts divided by 1 amp, or 5 amps. So the total current has to be equal to the current of I1 plus the current of I2, and so that was 2 1/2 amps plus 5 amps is equal to 7.5 amps. So that would be our current. Remember, I said that was additive. Now, if I know the total current, there's a couple of ways I can figure the resistance. If I know the total current in all the branches, I can use the equation where I know that the resistance is equal to the voltage over the current. And so that total resistance, if I know this current here and this voltage, well, that's 5 volts over 7.5 amps. And that comes into comes out to 0.67 ohms. Now another way of doing that, if you have, there's an equation, a longer equation, and that equation is, let me get a new sheet. That equation is that 1 over the total resistance is equal to 1 over R1 plus 1 over R2. And if we had more than one resistor in series, it would be 1 over R3 and so on. And for 2, this only works with 2. If we have 2 resistors, R total is equal to R1 times R2 over R1 plus R2. And let's see, our resistors were 1 and 2 ohms, if I remember right, over 1 plus 2 ohms, and that would be 2 divided by 3, which is 2/3, which is 0.66. And if I think I wrote 66, 667, it's 2/3, and there's another way to check it. So here, that's how we work with parallel circuits, parallel resistors, and calculating the currents and the voltages across those. Well, thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss any future videos, and please check out and subscribe to our other playlists on the Dan on Tech channel.